First of all, you can follow along on the web. There's tutorials on the Campus Grid website and SkeletonKey. Marco set the link. In terms of prerequisites for this, to follow along, you'll need a system that is running Red Hat 5 or 6, as well as web server that you can place files onto and then subsequently access using a web client. Let's get started with the installation. The first thing to do is to install SkeletonKey, and you can do this by grabbing an installer. I just okay. So we've grabbed the installer. I've already created a directory that I'll be installing it in. For the bin, which is empty currently. So there's that, and then I will run the installer, indicate that I want to install the binaries in the bin directory that's already there, and then I will say I'm going to export /temp in Chirp. And what the installer is doing now is it is going to the CC Tools webpage, grabbing the latest version of the CC Tools tarballs, downloading and installing it, and it's also going to the SkeletonKey website to grab the latest version of SkeletonKey, which it will also install. And now it's done. As you can see, /bin now has the CC Tools install in the CC Tools directory. Installer creates symlinks to some of the binaries in the CC Tools distribution for ease of use. It also downloads latest version of SkeletonKey and creates a symlink to the SkeletonKey script. And it'll also create this Parrot tar.gz that I'll explain a little more in a little bit. Okay, so now that we have this, the first thing to do is to verify that things are working correctly. So I'll just use the Hello World example from the website as a verification. This just is a simple script that will run grab the host name command, and it's being used to verify that the SkeletonKey infrastructure is working correctly and that everything's in the right spot. So first, I'll grab the configuration from the INI configuration from the website, put it in the file. Here, this is the tar.gz file that's found. It'll need to be placed in web server, so I'll get to that in a little bit, but for now I'll add the URL that it'll eventually be placed in. And here I'm just saying that SkeletonKey should run the bin hostname. All right, so that's done. At this point, I will then copy the parrot.tar.gz file to my public HTML directory to make it accessible on the web. I'll then change the permissions for it so that Apache will be able to read it. And then finally, I will run SkeletonKey on the Hello World example. Now there is JavaScript.sh that is the job wrapper, which will run my job, and I will then run it to verify that it's working correctly. As you can see, it'll go to the parrot.gz, download it, untar it, and then it runs the hosting command, and that's working correctly. So now we know that SkeletonKey and the infrastructure is working correctly. Next thing to do is a demonstration, and I'll show you how to do remote software access. And I'll be using R for my application that I am remotely running. So this is a little more has a little more moving bits and pieces. So here's my example file. Here I have a CVMFS section that I indicate that I'll be using the UC3 repository. This can be point to any repository, and you can also have multiple repositories specified. Next, I indicate where the repository location is, indicate the public key to use, and then give a web proxy that I'll be using to access this repository. And finally, I'll have the key that I'll be using to access the repository. Here I have the same script. I'll say that there's a shell script that I'll be using, and I'll have an application tarball that will be that SkeletonKey will download and run. Okay, so next bit is actually getting the bits and guts of things working. So here's the tarball here's the files that will be in the tarball. First, I have the actual script that I'll be running. One thing to note here is that I set up an LD path so that R will be able to access its libraries from CVMFS, and then here's where I run R from the CVMFS repository that Parrot will make available. And here's the script that I'll be running and some data files. Next, I'll just tar everything up into a tarball. And I will copy this to the public HTML directory to make it available on a web server. And then finally, make sure that the file is publicly accessible. And I will then run SkeletonKey on my INI file. And then run the JavaScript that's generated. As you can see here, what happens is SkeletonKey downloads the Parrot binaries, and then it downloads the R binaries, the application tarball, and the CVMFS repository key. Then it runs everything under the Parrot environment, and as you can see, R is now run through CVMFS. It ran through the data file and did some analysis, and the script finished. Okay. Okay. Yeah. That is looks like it's a slightly different version of the JavaScript that's actually been fixed in the latest versions. The key for your CVMFS repositories, it's for Sure. You should check with the publisher of your repository. I believe there are RPMs that you can get that have the Atlas and CMS repositories, or CERN CMFS repositories for Oasis. I think if you talk to the doc, you can get the key from them. And for local repositories, you should talk to the administrator of the repository to get the key. Yeah, for UC3, I already have the key. One of the administrators link in here, set that up, and I previously got the key from him and copied it to the demonstration file directory. Okay, any other questions? All right, so next, let me do a little demonstration of data access. So here I have a slightly similar file here. There's a different section, directories, which has the indicates what directories to export. Here the chirp base shows the base directory to export. I have two settings, read and write, that have a comma separated list of directories that I will be exporting with either read permissions or write and read permissions. These directories here are all relative to the base directory that I gave here. So when I say I want to have write permissions to slash, that actually it means that I want write permissions to this directory here. Likewise, when I say I want read permissions to chirp / read, that's actually Mount Hadoop users Thapa chirp / read. Here I indicate the application tarball that I want to use, and finally the script that I'll be running to do my read access tests. Okay, so here is the directory that has the files that I'll be using for my testing. The thing to note here is that for the infile, I actually use this direct environment variable called chirp mount, which SkeletonKey sets up, and this is the base of the directory that's being exported. So if you want to access that Mount Hadoop Thapa directory, you will access $chirp mount in your application. All right. So I will now fire things up. Okay, copy this over to my public HTML directory. And then change the permissions on the file. Okay, and then run SkeletonKey on the file. SkeletonKey will now talk to my chirp server. It will get a ticket from the chirp server that allows my application to authenticate and get authorization to access these files. As you can see here, it then gets the proper permissions for each of the directories here. So you have read permissions to chirp read. It has write permissions to /chirp and chirp stats. And then finally, I run the job script. Job script. And now it is reading right, remotely accessing files on the Chirp server, which is being exported, and reading from that. After a while, we should get some benchmark data back. While it's doing that, any questions? And there we go. So the script indicated when it started, when it stopped, and said that got it was able to transfer about the data at about 390 megabytes per second. Okay, so yes, yes, all the examples are available on the tutorials. They're slightly different in tutorials, but they have the same basic gist. You can see there are tutorials on just remotely accessing software using CVMFS. There's a tutorial on remote data access, and there's a tutorial on doing both, combining software and data access. The software for SkeletonKey is available on GitHub. Here, there's a wiki page on the wiki that has links to tutorial as well as more documentation.
So everyone, if you unclick, there is a little icon with a little microphone on top of the screen. You can talk and
So Suchandra, one question I think that naturally comes up is if you want to use SkeletonKey, it sounds like you need to have a web server close by. For example, on your interactive posts where you're submitting your jobs or where you're
Yes, you actually do need a a place to make files available on the web. This is so that you can put any application tarballs, your CVMFS repository keys, as well as the Parrot tarball. You'll need a Squid proxy server if you're going to be using remote software access. CVMFS goes through Squid for better performance, and if you don't have that, Parrot and libcvmfs will refuse to run or give an error. The requirements are actually outlined on the tutorials. In the prerequisite section, I outline what you need in terms of servers or what server environments in what OSs and that sort of thing are needed. Any other questions? I'm sorry? The Squid server. I was using a local Squid proxy on the UC3 data, the machine that I was running things on. It's actually, if you
My question is a little bit different, Suchandra.
At the,
you're in a campus grid environment. You have a host where you're doing your code development. You have another host where you put this web server. And there's a CVMFS repository somewhere. So as I go to start submitting my jobs, I need to know that you told me I needed a squid server. So where would I put?
Well, I'm not quite sure I understand. So if you specify the squid server in the
let me rephrase it, Suchandra.
section,
just in general, let's say I've got a cluster across campus,
and set their
and I'm going to use Parrot and Chirp
environment variable
okay.
that the
and I have a
job is
host.
running under, and it will set that to that squid server that you specify.
Is the squid server supposed to be somewhere close to the cluster, or
using
is it?
Okay. Mm-hmm. Yes. Yes, ideally you want a squid server that's on the cluster or very on the same network. But you can actually have a squid server located elsewhere as a fallback.
This is something that we're not really asking users to do, right?
The Madison team had
somewhere on your campus
set up squid servers on their own campus that jobs running elsewhere would use as a fallback, and that does work. It gives you
on the campus grid.
The performance is not as good as having a squid server on the cluster that your jobs are running on, but
we know very well, obviously, that a squid server is needed, but it's not something that the
no.